Let's see now. We have our information from the problem that we read up here on the board. First of all, we know that the Concorde flew a total of 3,525 miles. Secondly, it took 2.5 hours. Our problem is to find the average speed, or what's referred to as the rate of travel. Now, we all know that the formula distance is equal to rate times time will help us calculate this. Again, D standing for distance, R stands for rate of travel, and T standing for time. In this particular problem, we're looking for the rate. So in other words, this R is unknown. We happen to know the distance in this particular problem. The distance, miles, 3,525. So we'll substitute, or let's go ahead and label these. The 3,525 is the D, and hours, 2.5, that represents the time. Oops, that's the time. We already know it's 2.5. So we're going to write it as the T. Now, all we have to do then is take what we found to be D, substitute it into our equation, 35.25 equals, the R is the unknown. It is what we're looking for. We're looking for the rate or the average speed. So we'll leave that in, R times our T, and in this particular problem, T, or the time, is 2.5 hours. Let's go ahead and put parentheses around there. So basically what we've created for ourselves is a simple linear equation that we need to solve. We have 3,525 equals R times 2.5. With all of our work in solving equations, I'm sure you recognize that to solve this equation for R, what we're going to do is to divide the right-hand side by 2.5. And remember, whatever we do to one side of the equation, we do to the other. We're going to divide the left-hand side by 2.5. The easy calculation is right here. Those 2.5s divide out. We're left on the right-hand side with R, which is what we're after. On the left-hand side, we have 3,525 divided by 2.5, and that's equal to 1,410. Now, what does that represent? That is telling us that the rate of travel, or the speed of the Concorde in this case, is 1,410 miles per hour. Make sure, remember, when you're working with the word problems, that you always answer the question asked. The question was to find the average speed or rate, and sure enough we did. In this case, the solution is 1,410 miles per hour. Now, Einstein's theory is here. E equals mc squared. Our job is to take this equation and solve for m. What that means is we want to isolate or get m on either side of the equation all by itself. Now, to make it a little bit easier for us, because sometimes it's difficult for students to visualize which of these variables we're trying to solve for, what I'm going to do is write m in blue, and in your mind what you want to visualize is getting that blue m on one side of the equation all by itself. So it looks like this. E equals mc squared. Now again, don't be confused because there are so many variables. I know that sometimes students feel a bit anxious because they want to see some numbers in here. But in this particular equation, we have all variables, but that's okay because this is a big part of what algebra is used for. So here we go. Again, visualize in your mind that you want to get this blue m isolated or on one side of the equation all by itself. So I can see that what's standing in my way is that I have m times c squared. We learned in our work with solving linear equations that to undo multiplication, we're going to perform the operation of division. So in this case, I'm going to divide this side by c squared to eliminate it, but we also learn that whatever we do to one side of the equation, we're going to do to the other. So in this case, since we divided the right-hand side by c squared, make sure you divide the left-hand side by c squared as well. Once we do that, we see that the c squares on the right-hand side of the equation divide out. I'm left on the left-hand side of the equation with e over c squared. And notice the only thing left on the right-hand side of the equation is the blue m that I was trying to isolate. So this then would be the equation, that is Einstein's equation, solved for m. m equals e over c squared. Hopefully you're not too confused with this. Let's try another problem. Let's say that we have another equation, not necessarily anyone's particular formula, but just an equation. Let's look at this one. We have 8 minus 2, and in this particular equation, I'm going to want to solve it for y. So what I'm going to do is put my y in blue, so hopefully it'll stand out in your mind and you'll know that you want to isolate or get that y on one side of the equation all by itself. So we have 8 minus 2y plus 3x is equal to 0. Now again, we see other variables involved in this equation, but that's okay. Our goal here is to get this blue y on one side of the equation all by itself. We have a lot of work to do here, don't we? First of all, we see on the same side with the y, we have an 8 and a positive 3. So one approach to do this problem would be to subtract 8 from both sides of the equation and also subtract 3x from both sides of the equation, which is really okay. But I see just a little bit of a better way of doing this problem. I see a little bit of a shortcut, and that is this. Instead of moving both these terms to the other side of the equation, our other choice is to take the negative 2y, add it to both sides, and when we do, we have the 2y isolated on the right-hand side of the equation all by itself. So I'm going to choose that route because I believe it's a little bit shorter. So I'm going to add 2y here. And remember, my y is my blue letter variable. And when I add 2y to the left-hand side, I'm going to add 2y to the right-hand side. Now when I do, on the left-hand side of my equation, what I get is 8, negative 2y, positive 2y. That gives me my 0. Bring down the plus 3x. Bring down the equal sign. And notice now, on the right-hand side of my equation, I have 0 plus 2y, or simply 2 with the y. So far, so good? All right, now hopefully this is not too confusing for you, but we look over on the right-hand side of the equation, and we're almost there because we have 2 times that blue y. We want to get that blue y all by itself. What operation do we do at this time? We have 2 times y. To undo multiplication, we're going to do division. So I'm going to divide the right-hand side by 2, but whatever I do to one side of the equation, I do to the other. So I'm going to divide the left-hand side by 2 as well. Now, on the left-hand side, we have 8 plus 3x over 2. We could probably just go ahead and split this fraction and rewrite this as 8 divided by 2 plus 3x divided by 2 equals, and notice on the right-hand side we have what we wanted. The 2's divide out there, and all that's remaining on that right-hand side of the equation is that blue letter y. So this here, y, is solved for, or we solve this equation for y. The only one thing I can see we can do here is we can reduce this fraction. We have 8 over 2, so we'll write that as 4, almost forgot that there, plus 3x over 2, and that looks good to me. That's what y is equal to. So there's our blue letter y, and we've solved this original equation right up here. Here's our original equation, and we solved it for y. Now again, the procedure. Keep in mind that even though there are other variables involved in the original equation, that's okay. All you want to do is keep in mind that you want to get the blue letter variable on one side of the equation all by itself. So the procedure, get rid of everything that's by it, or in this case what we did was added it to both sides to isolate the term containing that blue letter variable. Once we did that, we used division here to eliminate the 2, because remember, to undo multiplication we can do division as we did. Finally, we get that blue letter y all by itself, which is what we wanted, and then of course we have to make any simplifications that are necessary. Hopefully, if you have another colored pen or pencil, as you're working through your homework problems, if you tried this method of using another color to highlight the variable you're solving for, it'll be a little bit more clear as you work through the problems.